is Shane Larson from Brigham Young University. I just graduated this past spring, and I'm glad to be here with you. I acted as the Global Body Design Lead, which was a big name for the guy that everybody talks to. And so just to sort of, there's 4 body teams, and they all needed to correspond to one frame team. And it made sense to have one person kind of fill that role. And I just wanted to tell you quickly the process that we went through, which was the teams made a lot of sketches, and they would select down to a few bodies to make 3D models of. And once the ID teams had selected a few bodies, then they would take that one more step and finally select down to their last body, which they would take the rest of the way and iterate upon with the frame team so that they would have one cohesive design. Unfortunately, no one was able to be here for Art Center today. I think we may see someone arrive in the coming week, and I would encourage you to talk to him about these designs. They're really great. And as you can see, the ID teams are the creative heart of a lot of things. They're very artistic. Sometimes the engineering has a little problem with the artistic side. But, so this is the Art Center's team. I don't actually know what they look like myself. I hope that it's not exactly like this. But this is their team, and Blair Taylor was their instructor. He also works for Volkswagen in California. I'm just going to present their designs, and I don't know all of the details. I would encourage you to ask Blair about some of these when he arrives. Hopefully he'll be here this week. So, this is the John Narcisco's model, as you can see, and there were several models. This is the Alias, the freeform surface modeling that they did, and you can see sort of how their designs advanced. Lots of creativity in the wing design from Art Center. And then I think there are several models here that I'm just going to show you the pictures for until we get to their final selection. Some great renderings. And also to mention about the Art Center team, they got really into this project. After they selected their final design, they didn't want to give up the other designs. They continued with all of their designs until the end, even though that wasn't required. And all the students finished their designs to the very end. And this is actually the model that was selected by Art Center. So this is their final model they chose. And they did a lot of great work there. I will now turn the time over to Nidzat Mutinovic to present the Monash design.
Hi everyone, my name is Nidzat Mutinovic. I'm a 4th year student in mechanical engineering and industrial design, and I'm here to present the Monash industrial design body team. Okay. So here we see our team members: Professor Mark Richardson, Kenneth Atted, and myself. So firstly, inspiration behind this project. One of the major points were in fighter jets and last year's KTM Expo concept. What's so specific about them is, for example, in the Harrier jet, as you see on the imagery, we see the relationship between the wings and the load, the way they carry it. And on the KTM Expo, it's the particular aesthetic that's created with the faceted body panels. So after some ideation, we brought everything down to about 3 concepts. And the first one here, as you can see it, is its major features are just a fluid design and just really flowing lines And one of the major innovations on it is a non-traditional rear wing, so placed in a position of which you'll hear some more details later on. So Concept 2, its major characteristic is that it really shows that inspiration from the Expo concept. So you see here faceted body panels and really contributing to a type of robotic aesthetic to the concept. Now, Concept 3, the major characteristic on this one is a really unusual treatment of air intake and wing, a really unusual take that hasn't been done before. And what we see here is so we've got the top body panel, and it really flows into the air intake and then reverses back on itself and goes through the top panel to create a rear wing. Now, to the refinement. Finally, we decided to actually develop concept number 2. We thought it had the most merit to create the best outcome. And as you can see here, what it really does is just picks on that concept 2 and gives it a bit of fluidity from concept 1. So we've tried to pick the best points from everyone and make it into a really homogeneous result in the end. Concept number 2, I mean, its main features were that the faceted body panels and the robotic aesthetic. And as you can see here, those faceted body panels really they emphasize a type of componentry that they emphasize body panels that are sacrificial, so guarding the vital running gear componentry. And what's also specific about that is that those body panels are really easy to exchange pit slots in the heat of racing. Now to further refinement and translating our sketches from paper to 3D. So as like the sketches, this was based on the standard Formula SE specs. 3,300 millimeters length and 900 millimeters in height. And what you can see here is a 50th percentile male, and the reason for that was that currently most racing drivers are of a small build. Now here is our first attempt at translating those 2D sketches into 3D in Alias, and as you can see, and as is usually the case, one struggles to convey it in motion, so the fluidity of lines, and that is the reason this is actually an iterative process. So our second attempt does that a bit better, so conveys the emotion, the expressiveness of the sketches a little bit better in 3D. And our third and also final attempt, where you can see, so on this imagery you can see actually the fully detailed final model, and that really does express what we wanted, and we were really satisfied with it. What you see here is our final design. So its major characteristics being the adjustable rear wing, and on the tyres. So what we see here is also an innovation. The tyre treads that also integrate with the alloy wheels. So the hubs. The tyre treads act as a tyre wear indicator, and these wheels are really characteristic in the way they're built. So the tyre is really pretty much molded around the hub. So that improves safety and also increases the rigidity of the tyre, creating more friction, so better traction. The colour scheme was inspired by last year's concept of VW IROC. So the electric, or really, or sometimes also called viper green, and some grey body panels. Now I will just cycle through some of the final digital renderings. So here we can see all the aspects of the vehicle, and from this digital model we went on to a manufacturing stage, which you will see in the